a few smaller improvements, but uh, some noticeable improvements at the same time. So we now have more transparency for the time nodes. So before, you would just see one number for the profit of the time nodes. We now split this up so you can see both the costs as well as the bounties and the amount gained while running your time node. And this just allows you to see a little bit more detail about what's happening on the DApp. As well, we've increased the security for the time node wallet. Before you would just enter in your password. Now to make that a little bit more secure, we prompt for the password at each visit. So this will help mitigate some security concerns that we had, as well as we've improved the signing for the time nodes. So some people were reporting some issues, and all of these issues have now been fixed, and the signing for the time nodes should be a lot smoother. So that's what we have from the DApp perspective. For those of you who haven't visited the DApp yet, just to remind you, it's at app.chronologic.network, and it's currently running on the Coven testnet. Now I want to talk about some other things that we've been working on as well. Besides the development, the team has been focusing on producing more written content. So we've been producing more blog posts, and I'll just show you a few of these. You can find these at blog.chronologic.network. Here's one written by myself. Our developer Piotr also wrote a really great one about the Chronos conditional scheduling, which is worth a read. And just today, our developer Daniel had a post published on Hacker Noon. So Hacker Noon has a lot of readers, and this post will definitely reach a lot of people and promote ChronoLogic in that way. So look out for more blog posts from the team. It's something that the developers are gonna focus a little bit more on and probably spend more time so that we can communicate the work that we're doing to the public and to the community. So now we can jump into what everybody came out for, which is the discussion on the claiming mechanism. So if you've been following the webinars, you already know a bit about the claiming mechanism, but we'll go ahead and start from start from the basics in case this is anyone's first time, just so you know why we actually have a claiming mechanism in the Ethereum Alarm Clock and why we're building a new one in the Chronos protocol. So the origins of the claiming mechanism came out of the Ethereum Alarm Clock, and it came out of this problem that we've been terming the transaction collision. So the transaction collision is when two users, in this case, two time nodes, we can call them time node A and B, both compete to execute a single transaction during the same block. So when this happens, only one of those transactions are actually allowed to successfully execute, and this is enforced by the smart contract. But the smart contract doesn't enforce, and there's actually no way to enforce how many time nodes send these transactions. So in the case that the time node many time nodes, or more than one time node, sends these transactions, which is what they're incentivized to do by the bounty. We run into this problem, and except for one, each of the transactions will get reverted, and those time nodes that had failed transactions will still have to pay the gas costs. So it turns into a bigger problem, and this was the motivation behind the claim mechanism. So to give you a little bit more visuals for that. So on the left here, you can just see there's two time nodes. They're both trying to do the same thing within the same block, which is about 14 seconds on the Ethereum mainnet, and it's a little faster on Kovan. So there's different possible arrangements. So one arrangement is that time node A gets its transaction to go through, while time node B gets its transaction reverted. The other arrangement is the opposite. Transaction B gets its transaction to go through, and transaction A gets reverted. And this actually leads to another problem because the person who gets to choose which block is actually mined is the miner. So in some cases, we might see a miner who runs a time node be able to actually front run their transactions in front of other time nodes. So the claiming mechanism is really important for the fairness and the crypto economics of running a time node. So the claiming mechanism was introduced by Piper Miriam when he realized this problem. We kept it, and we've been, of course, working on that as we've been working on both the EAC and Chronos. So the transaction collision was mitigated in the claim mechanism using essentially by moving it earlier in time. So it really just kind of moved the problem earlier and didn't really solve the problem in a foundational way. We still ended up having transaction collisions. They just happened before the execution and during the claim window instead. So the claim mechanism is less than ideal in the Ethereum Alarm Clock. The way we've kind of solved this has been in the JavaScript libraries. We check the transaction pool so that time nodes won't send any transactions if they see other transactions going to the same scheduled transaction. So essentially, if a time node sees that a transaction collision will happen, that time node will just take no action and prevent the collision in that way. But again, this isn't something that's enforced on a protocol level, so we consider it a less than ideal solution, and it's one of the major motivations in the Chronos protocol, and it's something we're trying to perfect now. So I'll go into a little bit about how some of the ideas we have there. So claiming in Chronos. So if you've tuned into prior webinars, you might have seen some of this or heard about this. But the first solution we considered and the first one we've implemented so far is the priority queue. So the priority queue is kind of a nice solution because it controls which time nodes are able to claim in a way that is based on how much that time node is willing to put as a bond. So we use the day token as a staking token. And when a time node wants to enter into this queue so that it can claim a transaction, it'll put up some day token as a bond. And the higher the value of that day token will determine where in the queue that time node enters into. And then that time node will be assigned based off of where in the queue that time node is. So I'll show you a little bit. This is a diagram. So you can see on the left-hand side the bond labeled Z1 from time node Z is 200 day. So it is at the front of the queue. That will be the first bond that will be assigned to a scheduled transaction. Following that is the bond from time node Y, and following that is the bond of 50 day from time node X. And you can see here that when Z puts in another bond, Z2, worth 100 day, that bond will get moved to the place between Y and X based off of the value of that bond. So that's kind of the idea behind how the queue works. And on the other end, when a user comes in to schedule transactions, those bonds will just get assigned to new scheduled transactions in the order of their values. So this is one way to kind of put some order to the chaos of transaction collisions by and to use the day token in a kind of crypto economic mechanism so that the more day token time nodes are willing to bond, the higher in priority those time nodes will be to claim. So at the current implementation, the priority queue costs about 100,000 gas to enter a bond into. So this will be the price that time nodes have to pay whenever they want to signal that they want to claim transactions. So right now it's not too much of a cost. We are still determining whether this is a better cost solution than what we had before, and expect to see some of those results and those numbers to come out very soon. But on the other hand, to remove the time node from the priority queue, so every time that time node is assigned, it only costs 42,000 gas. And this is actually mostly the work of another one of our developers, Anthony, or Autoboss03. He's been optimizing the priority queue, and he's gotten it down to a very low number here. 42,000 gas is pretty low of an amount. So we're feeling pretty good about this implementation so far, but we're not entirely sure that this is the most cost-effective solution because it's still using gas, and ideally we would have the claiming mechanism not use any gas or use as little gas as possible while still maintaining the security guarantees that we want from the Ethereum blockchain. So if you're interested in the implementation, it's on the GitHub. You can find it in the priority queue file in Chronos. And again, shout out to Autoboss03 for the optimizations he made there. So now I want to transition over to some of the more advanced stuff we've been working on within the last a week or two since EdCon. And to do that, I'll introduce another one of our developers slash researchers, Philippe. So Philippe, if you want to take over here.
Sure, thank you, Logan. Can you hear me well?
Yeah.
All right. So as Logan stated, the current approaches that we have require on-chain transactions, meaning that the time nodes need to deposit different bonds, and we need to reorganize the queue when the transaction is scheduled. And all these actions cost some gas, which end up having the user pay in the end, because the more expensive it is for time nodes, then the higher value the bounties that the time nodes will want will be. So if just to execute a scheduled transaction or to participate in a network, it costs me $1 per scheduled transaction, I will not accept bounties that are lower than $1. Otherwise, I'm losing money. So the lower the cost, the better it is for everyone. And one solution is, instead of having this queue mechanism or this priority mechanism on chain, there are ways to do it off chain. And the idea is basically that the time nodes among each other reach a consensus on what is the queue, and you can use, similar to what Casper does, the proof of stake algorithm for Ethereum. But in Casper, the way it works is the validators, the people that validate the blocks, stake an amount of ether, and the amount of ether that they stake gives them a higher chance. The more they stake, gives them a higher probability of being selected as a validator, which then gives them a block reward. In our case, the time nodes would stake DAI, and the whole idea is to find some sort of protocol that allows time nodes to reach a consensus on who can claim what transactions, and whoever deviates from the protocol is penalized or slashed. And again, this is very similar to how it works in Casper, where if a validator in Casper acts maliciously, tries to mine a wrong block or is invalid, unavailable, they get penalized by losing a portion of their stake. And that's a critical component to make sure that the consensus protocol works. So in our case, the way it would work is you have a number of time nodes that are going to stake amounts of DAI, and every time there's a transaction that it will be scheduled, a random value will be generated. And for the moment, for those who are interested in random number generation, we're going to use the block hash. And it has been deemed a security risk to use the block hash in the past for large amounts of rewards. So for people that use, for example, lotteries where you can win $1 million based on the random value, then the block hash becomes very insecure. And the reason for this is because the miner can basically decide or knows when they can decide can affect what the block hash is without betting in the case of a lottery. In our case, the bounties that the time nodes will have access to are going to be very low in general, or we expect them to be low meaning under $1 to under $100. This would still be considered low compared to millions of dollars of a lottery. And the risk of a miner manipulating the block hash to basically put themselves in front of the queue all the time is extremely low, because manipulating the block hash is costly. So that's what we're going to use for random value generation as of now. Of course, this is like an ongoing area of research, and we'll use whatever is the best to use. But currently, apart from people working on the sharding research on Ethereum itself, there's not a lot of good research on random value generation for smart contracts. So once we have this random value, yeah.
So what would we be using the random number for?
Yeah, so the random number, we're going to use it for ordering the queue. So once we have a scheduled transaction, which is the third bullet point here, when we have the scheduled transaction, we're going to basically create a queue where time nodes will be sorted based on the random value. And your probability of being in front of the queue will be proportional to the amount of DAI token that you stake. So for example, if Logan staked 99 DAI token and I stake one DAI token, 99 times out of 100, he would be the first one in queue and I would be the second. And one time out of 100, I would be the first one in queue and Logan would be the second one. And this scales really well with any arbitrary number of time nodes that want to stake. And now for every transaction, we have an order of who is the first online listing claim. So let's say we have a scheduled transaction come in, we have a queue, and Logan is the first and I'm the second. And then Logan decides that they want to claim this transaction, and what they do is basically they're going to sign a message using cryptographic signature. They're going to say, I, Logan, accept, I promise that I will claim this transaction. And then me, the second time node in the queue, know that Logan is going to claim the transaction. And if Logan decides to not to claim the transaction, Logan can sign a message saying, I, Logan, will not claim this transaction. Therefore, the next time node in queue can now state whether they want to claim the transaction. And you basically do that until someone along the queue accepts or claim that they want to claim the transactions. Now, yeah, go ahead.
So I would say, like, I guess one of the major differences between this, besides it being off chain, would be that we're still using like a queue structure, but the queue is now a probabilistic queue instead of being the priority queue that's enforced on chain. It's now because we're using the random number. It's now a more of a probability based off of how much day the time node holds.
Right. So the priority queue was mostly based on bonds that, and you could have multiple bonds. In this method of using this probabilistic staking or like sorting, you only stake once, and the probability of you being selected is proportional to your single stake. So you can have one time node with 100 day in it, or 100 time node with 1 day in each, and the probability of being in front of the queue is the same for both approaches. So might as well just use one time node and put all your day token. Now, because everything is off chain, there's nothing enforced on the blockchain itself. So what basically the logic here is that if every time a time node does something that is illegal or that we do not want them to do, then other time nodes can provide a proof that the time node that was faulty did something illegal, and then this time node gets penalized. So for example, if Logan is the first one in queue and I'm the second one, and Logan says, oh, I'm going to claim this transaction, and technically they're the first one in queue, they have the right to claim, but I decide to go on chain and claim the transaction directly on chain when it was not my turn. And then what Logan can do is say, hey, wait a second, I was the first in queue, I can prove that I was the first in queue, and nobody approved basically that me as a person, Philippe, it was not their turn, therefore /Philippe burned their stake because they claimed a transaction that was not theirs to claim. And you can apply similar logic. So if they don't state whether Logan, for example, does not say whether they want to take it or not, then after a certain amount of time is passed, the other time node says, okay, it seems like Logan is unavailable to answer, could be penalized or not, depending on where we want to go. And yes, all these kind of logics will basically be on chain, off chain, and we just need to make sure that we have a mean to prove on chain that a certain action was illegal. So basically here, it's a very common way of thinking with people working on state channels, where the blockchain is basically like a jury, or a court. So you basically, you don't go to court for every action you do, but whenever an action you do in the real world is illegal, then you're brought to court. And the blockchain here acts as a court, so to speak, for our off-chain claiming mechanism. And I mean, we don't have a proof of concept yet for this, so we're working mostly on developing the whole infrastructure and protocol design and crypto economics around this. But hopefully that's going to be done in the next few weeks.
Yep. Should we be expecting a blog post from you, Philippe?
Yeah, so we'll release a blog post on this specific approach, the more technical one describing in more details how it's going to unfold. Hopefully within the next month, we're also going to publish probably something on the random value generation, the research we've been doing on it for those who are interested.
Cool. All right. So let's, I guess, jump into Q&A unless there's anything else you want to cover.
No, I think I'd be happy to take some questions now.
All right. Let's do some Q&A. All right. So if anyone has any questions, we're willing to answer them right now. Go ahead and type them into the question box. All right. So we've got a question from Lowell Davis. Lowell asks, will we know what position we're in? So I assume he's talking about the queue, the off-chain queue. Philippe, do you want to take this?
Sure. If it's off-chain, you will know your position in the queue for a given transaction. But ideally, it would be just all the work, most of the work would be handled by your server or node that you're running. And it's important to also know that once you claim a transaction, then you know that you will have to execute a transaction in a later future time point. So the claiming itself is like not that critical if you don't choose to claim. It's really when you need to keep track of when you're supposed to execute a transaction once you claim it.
So you'll be watching it, so you'll know your position if you need to know it.
Right.
Yeah. Okay. So next question from Next Level. Is there a support for setting up a redundant time node using the same address to prevent loss of staked days due to unexpected interruption after claiming? So actually using the same address to run a time node isn't advised. And that's because depending on the volume of transactions in the network, that the time node might actually send out a transaction with a nonce, and that transaction won't get mined for a few blocks. So because each transaction has a nonce that depends on the last nonce and the last transaction, if a time node sends out a transaction that's not mined for a few blocks, it actually can't send out any more transactions until that transaction is mined. So it's actually more recommended to run multiple time nodes from different addresses. Next level. Um, so that's the answer.
Just to be clear, Logan, when you were saying different addresses, were you talking about different Ether address or different like IP address? Or
I was talking about different Ether addresses because the nonce is per address, per Ether address.
yeah, so I just want to try to rephrase the question. Maybe I interpreted differently, but I think the person asking the question was saying that what if I have a time node and I'm running it on my laptop and another computer, and then uh, my laptop shuts down for whatever reason, and then my time node is offline. Can I basically set up the same Ether address, so stake with two address using two different computers in case one of them fails? So if my laptop shuts down, at least I know that the other computer can still execute stuff. My laptop would be first, but if after like a minute my laptop doesn't respond, then the other computer kicks in basically.
So yeah, it is. So that is possible then. So depending on which way you meant that next level, he says he just doesn't want to lose days. Um, all right.
Yeah, so it's like most systems, you want to make sure that your system will not shut down, and if it shut down, you have backups.
So more on that later, I suppose. So Richard Hitchcock asks, where's this on-chain activity, or no, the off-chain activity happening? is it IPFS? So actually, what we're considering now is that the time nodes will actually have a peer-to-peer layer between them, so they'll actually be talking to each other. Um, so that uh, we may we may be using that, and that's a different thing from IPFS. So the IPFS is used for storage of transaction data, um, and that's actually something that we may not even need because the Ethereum events might actually be enough to store the transaction data that we don't even need to bring IPFS into the picture anymore. But as of right now, we're still, as we're implementing, we're going to see where things go. Next question from Alexander. Any consideration for amount of days you stake to give small bonus in your odds the more you stake?
I don't know if we're gonna have. It's probably gonna be a linear increase. So the amount you stake is the amount you stake divided by the total amount stake is your probability of being selected. There might need we might put well we'll most likely put a minimum uh, stake requirement, and that's to prevent some what is called griefing, where you can basically say that you will claim a transaction, then not execute it, and what you're basically losing is very, very small amount of money. So you don't care about losing it by not executing your transaction. So we need to make sure that when you say you will execute a transaction, you have at risk a large amount of funds, and large could be, I'm giving numbers like $100 or $1,000, and so that we have a like economical guarantee that you will execute the transaction, because you rather win $1 than lose 1,000. Um, but I don't see a bonus unless Logan has something else in mind.
No, I think the answer is about the same for my end. So I mean, it's just scales versus how much you actually put as a bond, um, because it's probabilistic. So yeah, not much more than that. Um, so we'll take these last two questions really quickly. So what happens if I set up two time nodes with the same address? Did we kind of answer that earlier, Philippe, or do you want to say more?
Well, kind of, so long as you make sure that you don't you might send multiple transactions. I mean, it's really a matter of making sure that the two time nodes you set up using the same address talk to one another, and they don't repeat actions or don't get stuck or properly repair each other's mistakes. But yeah, it's possible.
Okay. And then really quick, we'll just answer this one from Next Level. It's so this is more of a support question. Next Level about the encrypted wallet. Um, I think depending on when you made your wallet, you set a password. Whether you made that on my crypto or my Ether wallet. So if you can remember when you created the wallet in question, you might remember the password. And then we have so this is definitely the last question from Martin DeVries. He asks, is the audit that is being done right now on code that will be unchanged until EAC is live on mainnet? And if so, is the Chronos protocol with the advanced claim mechanism in addition to EAC that also must be audited first to then go live later on? So to answer the question, so yes, the audit right now is on the EAC. We're not bringing a lot of these experimental changes into the alarm clock. Um, Chronos is a separate project, and the development is happening at the same time, but we're kind of doing most of the experimental heavy optimization stuff in Chronos, and we're mostly leaving the alarm clock alone um, so the auditors have an easier time as they're working. All right, so that's it. That's it, guys. If you have any questions that come to you later, feel free to ask them in the Telegram room. All right, have a good day.
Thanks,
Bye.
everyone.